Okay, this is Unit 4, Lesson 7, using graphs to find average rate of change. So we have 7.1 temperature drop. Here are the recorded temperatures at 3 different times on a winter evening. Tyler says the temperature dropped faster between 4 p.m. and 6 p.m. Maya says the temperature dropped faster between 6 p.m. and 10 p.m. Who do you agree with? And then you will explain your reasoning. So if you look from 4 p.m., well, I don't want to do that. From 4 p.m. to 6 p.m., you have, that's just 2 hours. And then that is a decrease of 8 degrees. So if you have 8, that would be negative 8 because it's decreased, right? Negative 8 divided by 2, that gives you a negative 4. So that's decreasing by 4 degrees each hour. Okay, if you look at what Maya says, she says the temperature dropped faster between 6 p.m. and 10 p.m. Well, 6 to 10 p.m., that is a 4-hour change. And then it's decreasing by 9 degrees. So if we calculate that and say negative 9, because it's decreasing 9 degrees, divided by 4, that's going to give us negative 2.25. So looking at this, you can see that Tyler was correct because it dropped 4 degrees each hour, and from 6 to 10, it only drops 2.25 degrees each hour. So Tyler is correct there. So you could say, I agree with Tyler. The temperature dropped 4 degrees per hour between 4 p.m. and 6 p.m. It fell less than 4 degrees per hour in the evening. Okay, so that's just typing out who you agree with and why. 7.2, that's what we're looking at next. It says the table and graph show a more complete picture of the temperature changes on the same winter day. The function T gives the temperature in degrees Fahrenheit each hour since noon. So you have a table here and you have a graph, and they want you to find the average rate of change for the following intervals. Explain or show your reasoning. So we've got to look between noon and 1 p.m. So at noon, the temperature is 18 degrees. At 1, the temperature is 19 degrees. So it increased by 1 degree over that 1 hour. So the average rate of change for that, you would just simply have 1 divided by 1 degree per hour equals 1 degree. And then you could put 1 degree Fahrenheit per hour. Okay, so from between noon and 1, it rose by 1 degree Fahrenheit per hour. All right, so look at B, between noon and 4. So at noon, we've got 18 degrees. At 4, we have 25 degrees. So if you look at the difference there, it rose by 7 degrees over that 4-hour period. So you would have 7 divided by 4 gives you 1.75 degrees Fahrenheit per hour. That's your average rate of change between noon and 4. And then you have to calculate between noon and midnight. So at noon, it's 18 degrees. At midnight, it's 7 degrees. So this time it's decreasing. So it decreased from 18 to 7, so you would have a negative 11 since it's decreasing. And you have to divide that by the hours, the time that's went by, and that's 12 hours. And so that gives you negative 0.92 degrees Fahrenheit per hour. So your average rate of change there would be negative 0.92. Another thing you could do is you could look at your graph and connect those points for those corresponding times. And then you could look at the slope of those lines, calculate the slope. So let's look at number 2. Remember Maya and Tyler's disagreement? Use average rate of change to show which time period, 4 p.m. to 6 p.m. or 6 p.m. to 10 p.m. experienced a faster temperature drop. So on this one, I want us to draw our lines and connect those. So let's see, maybe. So from 4 to 6, you're going to connect the dot from 4 p.m. to 6 p.m. Try to draw as straight of a line as you can. Mine was not very straight. Try that again. It was a little better. Okay, then you're going to connect from 6 p.m. to 10 p.m. Okay, and so to see which one changed faster, which one decreased faster, or experienced a faster temperature drop, you would look at the steepness of the line. So looking at this from 4 to 6 p.m., that line, that's a steeper line than from 6 to 10. So just think if you were going down a slide. The slide from 4 to 6 p.m. is going to go faster, or you're going to slide faster than it would from 6 to 10 p.m. So that is a steeper line there. So it's going to experience a faster temperature drop. Always go back to that first activity that we did where we compared the 4 p.m. to 6 p.m. temperature drop and the 6 p.m. to 6 p.m. to 10 p.m. temperature drop, and we saw that Tyler was correct in saying that the temperature did decrease faster from 4 to 6 p.m. All right, so let's go to 7.3 now. We're looking at these graphs that show the populations of California and Texas over time. And we're going to estimate the average rate of change in the population in each state between 1970 and 2010. So from 1970 to 2010, we know that is 40 years. You could calculate that, 2010 minus 1970. And then you're just going to see how the temperature changes from that, in that time, in that interval. So we would look, in 2010, California's population looks about maybe 37. So we're going to say 37. And then in 1970, the population looks about 20. So 37 minus 20. And then underneath that, you're going to have your fraction bar as you're dividing this. And we will have, this is where we will find the difference of our years. So we'll do 2010 minus 1970, which we know that is 40. So let me draw that line a little bit larger. All right, so 37 minus 20, we're going to get that this equals 17 over 40, which ends up being 0.425 million people per year. So, and this is for California. All right. That gave us the average rate of change for California from the year of 1970 to 2010. Now we're going to calculate Texas, doing the same thing. So looking at Texas, that's that dotted line. It looks like in 2010, Texas had a population of 25. And then in 1970, it looks like 11. So we have 25 minus 11, and then we are going to have our fraction bar there, and underneath that, we're going to again take 2010 minus 1970. So we will calculate that, and we're going to get that that equals 14 over 40, which equals 0.35 million people per year in Texas. Okay, so we just calculated the rate of change for those populations during that span of years, 1970 to 2010. B is asking, in this situation, what does each rate of change mean? We could say in California, we could say on average, the population of California was growing by 425,000 people per year, and the population of Texas was growing by 350,000 people per year. All right, so California was growing by 425,000 people per year, and then Texas was growing by 350,000 people per year. Which state's population grew more quickly between 1900 and 2000? So looking at this, from 1900 to 2000, you could calculate this, or you could look at these graphs and the steepness of the lines. So looking at Texas, it starts out a little bit higher than California, but then it's quite a bit lower than California the rest of the way. And California starts out lower, but you can see it increases rapidly towards about 1950 and so on. It continues to just steadily increase even more. So the steepness of the line, the slope of that line for California is greater than the slope for Texas. So California is going to be the one that grew more quickly. So California's population grew more quickly between 1900 and 2000. And you could say the graph for California has a steeper slope or a greater slope. Either one is fine. Okay, so the lesson summary is always good to look at. I will show you something good in this. Right here, it talks about the average rate of change, and it shows f of b minus f of a. That's saying the output for function b minus the output for function a, and we divide that by the inputs of b minus a. And you can see that graph that goes along with that. It's always also good to look at. Okay, that is all for Unit 4, Lesson 7.